Hi guys, welcome to video lecture number 2. Last time we talked about atomic structure and subatomic particles. Today what I'd like to do is talk about how we can describe atoms. If I was asked to describe one of my kids, one of my sons or daughters, I would probably use their hair color and eye color, maybe their height or weight, and probably their personality. In the same way, we can describe atoms in 3 different ways. By talking about their atomic number, their atomic mass, and their net charge. Go ahead and pause the video and write the essential question down at the top of your Cornell notes. The first and maybe most important way that we can describe an atom is by using its atomic number. Atomic number is really very simple. It's the number of protons that are found in the nucleus of the atom. Take a look at the atoms on the right-hand side of your screen. Just a quick reminder from last video. Every atom has 2 main regions. The nucleus, where protons, these little blue dots, and neutrons, the red dots, are found, and the electron cloud, this gray area where these electrons, small black dots, are moving around. To find the atomic number of an atom, all you have to do is count the number of protons. So the top atom has 1, 2, 3, 4, 5, 6 protons, or an atomic number of 6, while the bottom atom has 1, 2, 3, 4, 5, 6, 7, and one hiding in the back of the nucleus, 8 protons, or an atomic number of 8. The atomic number is important because it determines the identity of the atom. It tells you what element the atom is. For example, an atom of oxygen has 8 protons, and an atom of carbon has only 6. So we'll talk a lot more about identifying atoms using an atomic number when we talk about the periodic table. But for now, it's enough to know that the atomic number of an atom is the number of protons that it has in the nucleus. The second way that we can describe an atom is by its atomic mass, or the mass number of the atom. The mass number is the number of protons and neutrons that the atom has. Both protons and neutrons have a mass of 1 AMU, if you'll recall from our first video. So both protons and neutrons contribute to the mass of an atom. Now, the atomic mass, all of the protons and all of the neutrons, represents the entire nucleus of the atom, which is really the only thing that gives the atom its mass or weight, because electrons are so small, if you recall, that they don't count. Now, a lot of people get confused about the atomic mass or mass number, and I think it's because the atomic number is just the number of protons. And so people want to make the mass number just the number of neutrons. But that's not the case at all. Both neutrons and protons contribute to the atom's mass, and so the atomic mass is the number of protons plus the number of neutrons. So to find the atomic mass of this lithium atom, we would count the protons, 1, 2, 3, and add them to the number of neutrons, 1, 2, 3, 4. The atomic number for lithium is 3 because it has 3 protons, and the atomic mass for lithium is the entire nucleus of the atom, protons plus neutrons, so the atomic mass or mass number for lithium is 7. The third and maybe the most complicated way of describing an atom is by its net charge. Remember from the last video that 2 of the 3 subatomic particles we discussed had an electrical charge. Protons have a charge of +1. So each proton in the nucleus of an atom contributes 1 positive charge to the atom. Electrons have a charge of -1, and so each electron in the electron cloud provides 1 negative charge to the atom. Neutrons were electrically neutral, or had a charge of 0. So when we're calculating net charge, neutrons don't come into the picture. Net charge is when you add all of the positive charges provided by the protons with all of the negative charges provided by the electrons. Take a look at the helium atom to the right. It has 2 protons, which provide 2 positive charges. It also has 2 electrons, which contribute to negative charges. The net charge is the combination of both positive and negative charges. So in this case, the net charge cancels out to 0. When an atom has a net charge of 0, it is said to be electrically neutral. When an atom has a net charge that is not 0, whether it's positive or negative, it's said to be an ion. Let's take a look at a couple of lithium ions and calculate their net charges. Again, protons have a charge of +1, electrons have a charge of -1, and neutrons are neutral and do not contribute to net charge of an atom. Now, in our first lithium atom, we have 1, 2, 3 protons that contribute 3 positive charges to the atom. And we have only 2 negative charges from our 2 electrons. The calculated net charge of this lithium ion would be +1. In the next example, our lithium atom still has 3 protons, which give it 3 positive charges. Notice that the ion still has 3 protons. Remember that atomic number identifies the atom for what it is. Because all 3 of these atoms have 3 protons, they are all lithium atoms. But they do have different net charges. This second atom only has a single electron, which means only 1 negative charge is contributed to the net charge of the atom. 3 positive charges and 1 negative charge give this ion a net charge of +2. It can go the other way. You can have more electrons in an atom than protons. This third example has 3 protons that contribute 3 positive charges, but it has 1, 2, 3, 4 electrons that contribute 4 negative charges. The net charge of this final atom is -1. All 3 of these atoms are lithium atoms because they have 3 protons, but all 3 of them have different net charges. Even though they have different net charges, they are still all ions.